Welcome back, dear students who are watching this live classes of the UAE. In fact, it's a chance for grade 12 students to go through the contents already I've done in the school. You take it as a revision process for you to prepare for the examination. So before the break, we are talking about the basic concepts of resonance and related aspects, applications which we deal in the chapter alternating current circuits in grade 12. Okay, further I had explained one of the numerical problems usually coming in the board paper. That also I said, like that's actually given as a worked out example in the textbook as well. One of these similar questions is given there. That is to find out is the algebraic sum of the voltages greater than the source voltage, if not, what is the reason? That's the question there, we discussed already. One more question I'll first explain out about, then I'll show you some questions from the papers. Okay, see, first of all, the question I'll tell you, there is a coil, okay. This coil, when connected to AC circuit of 100 volt 50 hertz, okay, then what happens is 1 ampere current flows through it. So when it is connected to 100 volt 50 hertz AC source, 1 ampere current flows through it. But if it is connected to a DC source of simply 100 volt again, 100 volt DC source, okay, so this is, let's take it like this, 100 volt DC source and 100 volt AC source. If it is 100 volt DC source, same coil carries a current of 2 ampere. So once again the question is, 2 ampere current flows when it is connected to 100 volt DC source, and when the same coil is connected to AC source of 100 volt 50 hertz, only 1 ampere current flows. Okay. The questions are, why is it so? That's one thing. Second question, what's the value of resistance of the coil? Third question, what's the value of impedance of the circuit if it is an AC circuit? Third question, what would be the inductance of the coil? When you say a coil, the coil is made up of a wire. Normally when we talk about inductor, we say it doesn't have a resistance, otherwise we say resistance is negligible. That's what normally we say. But actually when the real situation is what? Coil means it has inductance, plus it is, because it is made up of a wire, it has got even resistance as well, right? Resistance and inductance both. So that's the situation you should think of in this case. So when it is in a DC circuit, only 2 ampere current will flow. In AC circuit only 1 ampere current flows. First question, why is it so? Why? First thing we can say, in DC circuit the opposition, I told you about that, the opposition is only due to resistance, only physical opposition to the flow. Whereas when it comes to AC circuit, in addition to resistance, it has got reactance as well. The inductance also plays a role. Otherwise you might have studied the concept of self-induction. Self-induction also is there. So in an AC circuit, in addition to resistance, there is reactance as well. That means there is more opposition, right? That the total opposition is what is termed as impedance. So simply in a DC circuit, if you find V by I, that is R. In AC circuit, if you find V by I, that is impedance Z. That's here AC 100 by 2. So 50 ohms is the resistance. So we get resistance as 50 ohms. Right, so one answer we have, R is 50 ohms. How about impedance? Impedance is again V by I here is 1 ampere. So impedance is 100 ohms. So one more answer we got. Okay, resistance, impedance, these two answers we have. Now we are going to find what else? Inductance, L. We know the equation impedance is root of R squared plus XL squared. Okay, make use of that equation and you may rearrange and get the value of XL as what? Root of R squared plus root of Z squared minus R squared. So on rearranging we will get like this. So we have Z, we have R also. So I will write it here. Therefore what will be XL? XL is root of 100 squared minus 50 squared. Correct. So this is what you are getting, and you will get the answer as 50 root 3 ohms. That is reactance. If you know the reactance, what's the question? But remember, don't get confused with reactance and inductance. Sorry, inductance is L. Okay, whereas reactance is XL, which whose unit is ohm. Inductance unit is Henry. Okay, so here therefore what we will write is, instead of XL, so here we are going to find L, not XL. Okay, so instead of XL we write omega L is 50 root 3, but omega is 2 pi nu L is 50 root 3. L is the question. Okay, you are given nu as 50 hertz. So we will get L is equal to 50 root 3 divided by 100 pi, this much Henry. Okay, so root 3 by 2 pi Henry. So the value of L we are able to calculate like this. Hope it is clear. Okay, value of L we can find out from this. Okay, this way. That's one thing to know. Now I will show you some of the questions which were asked in the recent past papers. So as I mentioned at the beginning of today's class, there are many question papers right now available in CBSE's website. So all of you are requested to go to the site. All the subjects, all the question papers of different regions along with the marking scheme are available. So make use of them. Okay, so most reliable answers to the CBSE examination questions are from those marking schemes. Okay, because it is published by the CBSE. Okay, and the next thing is, recently we had exam in month of July. There was a compartment examinations. So one of the papers of the compartment examinations I have with me now. After that we will see the sample question papers as well. Okay, anyway, have a look at the question. Just watch on the screen. I hope you know this. You saw this. First question asked is, why are electric field lines perpendicular at a point on the equipotential surface of a conductor? This is the first question. Okay, why are electric field lines perpendicular at a point on the surface of an equipotential surface? At a point on the equipotential surface of a conductor. Okay. Okay, I hope all of you have seen this. This is actually the real question paper of CBSE compartment exam. Okay. So can anyone make out what's the answer to this? Why electric field lines are perpendicular to equipotential surface? See, one of the similar questions we have discussed in the first chapter is related to electric field. Okay, electric field lines are perpendicular to a charged conductor. We studied that. But here the question is, if there is an equipotential surface, suppose this is an equipotential surface. On the equipotential surface, anywhere if you draw the electric field line must be perpendicular to it. This must be the direction of the electric field. Why? That's the question. Why are electric field lines perpendicular at a point on the equipotential surface of a conductor? So the answer I will tell you now. First of all, equipotential surface means there is no potential difference, same potential throughout. So between any 2 points if you take on the surface, there is no potential difference. No potential difference means no flow of charges. Right? Charges do not flow through the surface. You know, for charges to flow, there must be a potential difference. So here between any 2 points if you take into account, there is no potential difference being equipotential surface. No potential difference means no movement of charges through it. No movement of charges means there are no any forces acting on this. See, if electric field line was not perpendicular, suppose it was like this, then what would have been the situation? There would have been a component of electric field. We can divide electric field into, you know, the concept of resolution of vectors. We can divide this electric field into 2 components, horizontal and vertical components. The horizontal component will make the charge particle flow now, but there is no flow here. That means there is no such a component here. There is no component along the surface. So it shows what? The full electric field is perpendicular to it. So if the electric field is perpendicular, this should be 90 degree. Okay. If the electric field is perpendicular, then only there won't be any component of electric field on the equipotential surface or on the surface, then only we can say there is no movement happening. Once again, electric field lines are perpendicular to equipotential surface because on the surface between any 2 points no potential difference, so no movement of charges, so there is no any component of field through the surface, that is the electric field must be perpendicular to it. Okay. Now look at the second question. A variable frequency AC source is connected to a capacitor. Will the displacement current change if the frequency phase source is decreased? That's another thing to be clear about. Will the displacement current change if the frequency phase source is decreased? Okay, hope all of you have seen the question. Okay, now you listen, I will explain. You know, in the case of a capacitor, sometimes you must be, sometimes at least some of you might have confused about this aspect, like capacitor is connected in DC circuit, say in the circuit like what we have studied in current electricity. When a capacitor is connected like that, the battery doesn't allow the current to flow through the capacitor, it is blocking because there is dielectric in between. Okay, blocking is there, right? But if it is an AC circuit, why then there is a flow? In AC circuit, capacitor will allow current to flow even if there is dielectric between the plates, even if there is an open space between the plates of the capacitor, current is flowing, which is against what you studied in the chapter current electricity. So as far as a DC circuit is concerned, capacitor is making the circuit open like a switch, open switch, no current flow. But in AC, why is it so? Why the current is flowing through this? There the mechanism is little different. That's what exactly we are doing in the chapter electromagnetic waves, the concept of displacement current. So when alternating current is passing through the circuit, the alternating current has got, when alternating current is passing through the circuit, what type of current it is? Varying current. The value of electric field between the plates of the capacitor keeps on changing. So there is a time varying electric field between the plates of the capacitor. This time varying electric field causes, according to Maxwell's theory, the time varying electric field between the plates will cause a sort of current called displacement current. So if there is a current in the wire, that time there will be current in the, if there is a continuity of the current, that current is called displacement current, but that current arises due to the time varying electric field. That's the concept to know. Okay, so in AC circuits there is a time varying electric field between the plates of a capacitor. This is causing a current, that is displacement current. That's why it is not blocked. Okay, it's continuous. Conduction current and displacement current are equal. Okay. Now here the question is, what happens to the displacement current when the frequency of the AC source is decreased? That's the question. So that means, you know, the equation for the current in AC circuit in capacitor is I is equal to V by XC, right? But what is XC? XC is 1 by omega C, that is omega C V, that is current. So here what happens is the frequency is decreased, then what will happen? Current will also be decreased. That's the concept. Okay, when frequency is decreased, current will also be decreased. When frequency of the AC source is decreased, what happens to current? That is one question. Okay, so now another question. You see the question number 6. Just look at the screen. Okay, you see in the question, this is a question that is definition of electric flux and SI units. What's the flux due to electric field? E is equal to 3 into 10 raised to 3 I cap Newton per Coulomb through the square of Sept. This is actually a textbook question only. So what you can make out from this is a simple question. I'll just give you the equation, then we'll proceed to the next one. Okay, look at the board. We have the equation phi is EA cos theta. Electric field is along the x-axis. Okay, and the normal to the electric field, if it is kept, there a point to be clear about is this area vector is important. This area vector and electric field vector, if the plane is kept normal to the electric field, that means the area vector and electric field vector in the same direction. So theta is 0. So what happens is, here the flux is equal to simply electric field into area. Area being square, you can say area is the side, area is side squared, A squared. Okay, so this is the value of electric field is given, side is given, but remember it's in centimeter, you have to convert it to meter, that's it. Okay, that many Newton per Coulomb meter squared. that is the flux. Okay. Now look at another question. See the next question. See the question on the screen. I hope some of you might have done this question already. The question is, calculate current drawn from the battery by the network. Okay. I hope all of you are seeing this diagram. Okay. So, you look at the this resistance, which one, that 5 ohm. Okay. So, this resistance is if you compare it with Wheatstone's bridge. So, what do you make out is, it is a Wheatstone's bridge format only. So, this resistance, that is, we know the resistance between B and D, that resistance is the, that center one, you know, you must be remembering the diagram of Wheatstone's bridge. Okay, it is the center one. Then what happens is, the other resistance, look, this is 1 ohm and the other one is 2 ohm. Okay, just look at the diagram, 1 ohm and then 2 ohm. So, P and Q, P by Q, you know what is the concept of balanced Wheatstone. So, these kind of questions, what you should first see is, check if the Wheatstone's bridge is balanced or not. If it is a balanced Wheatstone's bridge, how do you make out its balanced Wheatstone's bridge? That ratio P by Q should be equal to R by S. Check that. Here look at the diagram. What do you understand is 1 by 2 is equal to 2 by 4. You look at the diagram. You can make out from the circuit 1 by 2, the top part. See this one, 1 by 2. Okay, P by Q. The same ratio is 2 by 4 also. Okay, so the ratio is the same. Since ratio is the same, it is a balanced Wheatstone's bridge. If it is a balanced Wheatstone's bridge, further what you can make out, the 5 ohm, that resistance is taken out. Then how will you redraw this? 1 and 2 are in series. Okay, and further what else? This 2 and 4 are also 2 and 4, that also in series. Okay, so these two, okay, they are in series. 1 and 2 in series, that means 3, 2 and 4 in series, that is 6 ohm. So, what you get at the end, 3 ohm and 6 ohm, they are in parallel. 6 and 3 in parallel simply means the total resistance is 2 ohms. If total resistance is 2 ohm, the current drawn is how much? High current is total voltage by total resistance. So, 2 ampere. Okay, so this is the concept about the calculation of current from Wheatstone's bridge. Hope all of you have got a clear picture about what is the situation of this kind of questions. Okay, once again, if a circuit of this sort comes, first you check, is there any provision for series parallel combinations to be found? If not, check if it is possible to frame Wheatstone's bridge. After framing Wheatstone's bridge, you check if it is balanced Wheatstone's bridge or unbalanced. If it is balanced Wheatstone's bridge, just follow this method, just delete that second or center resistance and remaining two resistors in parallel, sorry, first two resistors in series, then those 2 resistors will become in parallel as I explained here. Okay, this I hope it is clear. Now, last one more question you will see. Just look at this question. Have a look at the question. A square loop of side 20 centimeter carrying 1 ampere current is kept near an infinitely long straight wire carrying current of 2 ampere in the same plane as drawn. Okay, question, calculate the magnitude and direction of the net force exerted by the loop due to the current carrying conductor. So, this again is an important type of question. Listen. So, I will quickly explain because we have to wind up the classes. Before that, I will just explain this question. Listen carefully. Okay. So, there is a straight conductor. Okay, this carries current 2 ampere and this is a square loop, set a distance, side 20 centimeters. There is a current of 1 ampere flowing through this also. Okay, what you are going to find is magnitude and direction of the net force exerted by the loop. Okay, very first thing to understand is, you just see what is the direction of the magnetic field at this point due to the straight wire. You know, you may use a right hand rule. Okay, right hand thumb rule, you hold the conductor like this. Okay, see this finger into the plane. So, what does it mean? The magnetic field at this point due to the straight wire is into the plane, and you know the direction of the current is clockwise in the loop. So, the magnetic field due to the current loop, otherwise dipole moment due to the current loop also is into the plane. So, dipole moment is into the plane due to the current loop and the magnetic field is due to the wire is also into the plane. So, what do you make out therefore? We see that M and B in the same direction, it shows there is no torque. You know the equation for torque is tau is equal to mb sin theta, theta 0, torque is 0. Okay, there is no torque, but there is a force. That force, how do you find? Between these two there is a force of attraction. You know, current is in the same direction, means force of attraction. Between these two there is a force of repulsion, but repulsive force is less, you know, because it is at a greater distance. So find attractive force and repulsive force, then subtract. Which equation we will use? Force per unit length is what? Mu 0 I1 I2 by 2 pi R1. This R1 is given in the question, it is given this as 10 centimeter. This is R1, correct? That is the force per unit length between these two wires. And between these two wires, how do you find force per unit length? Mu 0 I1 I2 by 2 pi R2. Here R2 is how much? This whole distance is R2, that is 30 centimeter is R2. 30 centimeter is R2. Okay, 10 centimeter is R1. So find the difference between the two. So this difference is the force per unit length between the two wires. Okay, if it is per unit length, then what you should do to find the total? Into the length of the wire. Length of the wire is 20 centimeters. Again convert it into meter. So this is the expression for force. You see, the force, net force on the loop is calculated using this way. See, R1 is 10 centimeter, R2 is 30 centimeters. I1 and I2 are given, force per unit length is what is given here, into length which is 20 centimeter will give you the total net force. Okay. So I hope all of you have got through this chapter, and all of you caught certain ideas related to the chapter AC and relevant questions as well. Actually, I have lots of questions in store with me, and some of you might have done all these. And next class, which is going to be in the next week, we will again solve some of the questions from the past papers and sample papers. And during this time, you keep collecting your doubts and keep them ready. And when we have a live session next time, you take the questions and call and find out what the answer is. I'll be able to help you out. Okay, this program is yours, and keep watching this program. Stay tuned with NTV, and we will have a brand new live session or live classroom next week with new questions from physics. Till then, bye bye.